We're going to review digital electronics. I am in chapter N, toward the last part of the chapter. The first thing with digital electronics is to know that we're going to have two choices, a 0 or a 1. We're using binary. 0 can be thought of as being a false statement, 1 as true. 0 could be no, 1 could be yes. So the inverter basically changes your mind. If you have no at the beginning, we have yes at the end, and vice versa. Here's a symbol for the inverter gate. If A is 0, Y is 1. If A is 1, Y is 0. Just the opposite. It inverts the logic. It's like changing your mind, or think of it this way. You make a statement, the sky is blue, not, and then this is going to flip the logic. So whatever is true or false here, over on this side, it's the opposite. The next gate is the AND gate. Think of AND as having two conditions that need to be met in the simplest case. We'll consider going out on a date. Let's say that we want our prospective date to be attractive to us in some way. Perhaps we want to date a musician. And we'd like our date to be polite. Now we're going to go through all the possible cases, and here we do it in a neat form like binary counting. We start with no for the first one and run through the two choices here, no and yes. Then we make the first choice yes, and the second condition no and yes. We run through all the cases. So these are really the conditions, and well, technically the choices will be over here. We make our decision. So here the prospective date is not attractive and does not have polite manners, no date. Not attractive but polite, no date. Attractive to us in some way, not polite, they're stuck on themselves, no date. Attractive to us in some way and polite, we go on the date. Now we replace these with the nice zeros and ones. So 0, 0, 0, 1, 1, 0, 1, 1 are all the cases. And here, if the two conditions are false, then the decision is no. If one of the conditions is true and the other false, the decision is still no. If both conditions are true, are met, then the decision is yes. Here's the symbol for the AND gate. And we're off to do OR. OR is going to be true if either condition is met or both. Here's my example. We go to Grandma's for lunch, and lunch says you can have sandwich, you can have soup, and you can have both. The question here, or our output, did you have lunch? Well, no, 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 yes, yes, no, yes, yes. These are all the possibilities. And here you can see you have lunch if you eat the sandwich or have the soup or do both. So it's a 0 and all ones for the logic. Think of this as OR giving you the hint as to what to do. Either of these need to be true and we're good. We're good to go. Now, the symbol for the OR is this gate here. And the next one is the exclusive OR, where Grandma says you can have one or the other, but not both. So in that case, we have to exclude pigging out with both the sandwich and the soup. You can only have one. There's not enough to go around. So it's 0, 1, 1, 0, and this is the exclusive OR gate. You have to memorize these symbols just like you memorize words in studying a foreign language. The next gate is simply obtained by negating the AND gate. It's not AND, say, so it's AND reverse. So here for AND, we had all these zeros and 1 when both conditions were met. Now we flip it. Now you can think of this as a practical question. Did you stay home, say, if you when the date question comes up? So here is the reverse answer as to before. If we don't go on a date, well then yes, we stay home. If we don't go, yes. If we don't go, yes. And if we do go on the date, then we don't stay home. So here is how you can think of that. You do the and condition, and then you just say not, which means you flip it. 0 goes to 1, 1 goes to 0 at the very end. The NOR gate, very similar. You use the OR condition and then not it. Here you could ask the question, did you fast? Well, you fast only if you eat nothing. See, so that's the flip of the question we asked before, which was, did you have lunch? So you simply think of the OR condition and then not it, and then you have the truth table. So here, symbolically, it's OR, not. Just flip the answer. So the NOR gate is abbreviated with the little bubble on the end, just like the NAND gate. You can replace the inverter with a little bubble. And sometimes they say that this is a bubbled AND and a bubbled OR. NAND and NOR respectively. The exclusive NOR is the reverse of the exclusive OR. And the exclusive OR was, if you recall, that would have been here if we go back up and just double check that for the exclusive OR. We have 0, 1, 1 in the middle, and then 0. So we have to flip that, and by flipping that, we have 1, 1 at the ends and 0, 0 in the middle. An example I gave here in this book is if I'm trying to balance myself and A is put a weight on the right hand, B is put a weight on the left hand, and then I ask the question, am I balanced? I'm balanced if I have no weights, and I'm balanced if I have a weight on each arm. So it's an all or nothing. And in class, the students gave me a nice one. They said, you here love your significant other, if this is a 1, and your significant other loves you, if this is a 1. And they said it's better to not have a one-sided relationship where you do not love your significant other and your significant other loves you, or vice versa. It's better to not be in love or to be in love, all or nothing.